Ozonolysis of an alkene followed by treatment with dimethyl sulfide forms the following as the only product. Identify the alkene. So here's the reaction that we are talking about here. So if you have an alkene, let's go ahead and put some R groups on here. So I'm just gonna make them all the same and assume this is a symmetrical alkene. If we treat this with ozone, followed by work up with dimethyl sulfide as described in the problem, what's gonna happen is we're gonna get an oxidative cleavage of the alkene. This is an ozonolysis reaction. Right, so lysis implies breaking apart, and we're saying that we're also oxidizing it. So what we're gonna do is we're gonna break that alkene and you end up oxidizing both of the carbon atoms. So a shortcut we saw previously is that we could just redraw the alkene and know that we are going to cleave that bond and replace it with 2 bonds to oxygen. All right, so you can see here with this acyclic general alkene, when you break it apart, you get 2 pieces. So if we look at what we're given here, we should notice that the carbonyls are attached to the same chain. So why is this important? Well, if they're attached to the same chain, that means that they used to be attached together. So this means that we had a cyclic alkene, right? Because if we had an acyclic alkene, we would have broken it into 2 carbonyl fragments. Instead, they're attached to each other. So what we want to do is we want to number between the carbonyls to see what size ring. So that's what we're going to do as our strategy. So number between the carbonyls, so that's inclusively, we're including those carbon atoms. And we're doing this so we can see what the ring size was. Okay, so I'm just going to start at 1 and I'm going to count to the other. I'm not worried about IUPAC numbering here at all. I'm just keeping track of carbon atoms. So 1, 2, 3, 4, 5, 6. So that tells us that we had a 6 carbon atom ring and we had an alkene, okay? And so these 2 carbon atoms are these 2, so I would have to start numbering to go around, and I could have started here and went the other way, it doesn't matter. And again, this is not IUPAC numbering, so let's actually make a note, not IUPAC numbers. So this is completely unrelated to nomenclature. This is just trying to keep track. All right, and then I want to look and see what we have here still. So we still have a methyl group right here on carbon 1. So let's go ahead and put that methyl group on carbon 1. And we can see on carbon 6, we see 2 carbon atoms. So we have an ethyl group there. And so we can put that ethyl group on carbon 6. Right? Because if they're there in the product, they must have been there in the original alkene. And then hopefully we can quickly pick this out as being option A. And if you want additional practice with ozonolysis, go ahead and cleave all the rest of these alkenes just to see what you get as products.